Euclidean geometry, the chord theorem proofs. These are the first real theorems of circle geometry, so all we know at this stage is the radii are equal. But the first one, the line segment joining the center of a circle with the midpoint of a chord, is perpendicular to the chord. And then the second one is the converse of that. The theorem says if this then that, if midpoint then perpendicular. The converse will say if perpendicular then midpoint. So we have the perpendicular from the center to a chord, and it bisects the chord. That's the converse chord theorem, but we refer to it as the chord theorem. That's fine if you do that. You don't have to say converse. It's simply a case of proving triangles congruent. That's all we can do, because that's all we know about the circle at the moment, is that the center is equidistant from all points on the circumference, the radii. Proving the first one, we need to have a given in this case. If you've seen my previous videos, you've seen that I've said you don't have to put given if you can show it in a diagram, but in this case we cannot show that O is the center of the circle. So we say O center. Required to prove, we interpret from there to the diagram. So perpendicular to the chord, so therefore we're going to say OP perpendicular to AB. Construction, we're going to join OA and OB, so we have our triangles, and we do a congruency proof. I'm not going to go through it in great detail because I'm sure you've done congruency before, or if you're at this stage of geometry, but we have equal given, equal radii, and common. So therefore, by side, 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 these two triangles are congruent to one another. Now we need to prove that this is perpendicular, which means we actually have to prove these two angles are equal to one another. And with them adding up to 180, being supplementary, that means that they're 90 each. And there's your perpendicular. So here we go. P1 equals P2 because of the congruency. But we argue P1 and P2 add up to 180. They're supplementary, adjacent angle, straight line. So therefore, they are 90 each, and there's your perpendicular. The second proof. Given, once again, that O is center. Required to prove, we interpret from there. So perpendicular bisects the chord. So we're proving that AP equals BP or AP equals PB. Construction, same thing. Join to obtain your two triangles to prove congruent. Now in this case we have a common side, we have radii, and we have this equals that, being perpendicular. And this is a special case of the non-included angle for congruency, right angle hypotenuse side. So there's our proof. OA equals OB, radii, P1 equals P2 equals 90 degrees, given that they're 90, and OP is common. So therefore, right angle hypotenuse sides, the triangles are congruent. And we go straight there. We need AP equals PB. We'll have a look at AP, second, third letters, BP, second, third letters. There we are. And it's done.